In this video we will study tossing a coin 10 times and finding the probability of guessing 2 correct true false questions from 3 out of 10 using permutation with identical items and with restrictions. So we have the following issue. A true-false test consists of 10 questions. What is the number of all possible outcomes or the number of elements in the sample space? So any element in the sample space is an ordered sequence of correct and not correct. So the question will be marked C as correct or N as not correct, and this sequence is composed of 10 objects such as this sequence here. This sequence here can be generated out of this set which contains only 2 objects, C and N. So to know the number of elements in the sample space, we can apply the multiplication principle for 10 disjoint sets and in order. So after answering all the questions, any question can be either correct or not correct. So it is as if we are withdrawing C or N for the first question, C and N for the second question, and so on. So there is 2 ways for each question to come out as correct or not correct. And the number of ways that all these 10 questions may come out as correct or not correct is the multiplication of all these ways, and that is 1024 ways. And these are the number of ways this true-false test can be answered. It can be answered in 1024 ways. There is another way according to which we can find the number of ways to answer this test, and that is by looking at the sequence of correct and not correct answer. We can see in this sequence that correct can be repeated more than once and not correct can be repeated more than once, so that means replacement is allowed. And the other thing is, if we change the order of answering, we are going to change the result of the test, so that means order is important. So in this case we have 2 conditions: replacement is allowed, order is important, and we can apply the formula of permutation with replacement for n objects taken R at a time. So n is the number of objects in the set, which is 2, so we have either C or N, and R is the number of objects in the generated sequence, and that we have 10 objects, or R is the sampling size, which is also 10, and we apply the formula by substituting n with 2 and r with 10, and we get 2 to the power of 10, and that is 1024. So we have 1024 ways of answering this test, and that is the sample space. Question number 2. Find the probability of guessing correctly on question 8, 9 and 10 exactly 2 times. So we are going to answer question 8, 9 and 10, but 2 of them should be correct. But before we answer this question, we have to see the ways of answering these questions. We may answer all these questions correctly. We may answer 9 correctly, 8 correctly, 7, 6, 5, 4, 3, 2, 1 correctly, or 0 question answered correctly. And we have to notice that the permutation of these elements will generate all possible outcome of answering true-false question randomly. So now we have to notice that to find out, guessing 2 questions out of 3 correctly, we must have 2 correct and 1 not correct. So we must have CCN at each sequence we need to deal with. So we notice that the first sequence doesn't have that, but these sequences here, they have it, and the last 2 sequences, they do not have it. So these sequences must be crossed off and we cancel them out. So we are left with these sequences. So let's now rearrange them. So we move these sequences up and these sequences down and back to the left, and now we have all these sequences in order and ready for the calculations. But we have to pay attention that the question demands from us that these 2 correct question and not correct question, they should be located at question number 8, 9 and 10 in the test. So this is the case for the first sequence, but for the second sequence we have to move this CCN to the very end and move this N here behind it, and the rest of the sequence will be prefixed to it. And for the third sequence we have also to move the CCN to the very end in order to be in the location of 8, 9 and 10 questions, and we take these 2 N's to the back and we write the rest of the sequence. And we keep moving the CCN to the end for each sequence. Keep doing the same thing exactly until we finalize all the sequences. And now we have all the cases of sequences in which CCN is exactly at the location of 8, 9 and 10 question in the test. And now let's start shifting all these sequences to the left in order to start our calculations. So to find the number of possible outcome and do our permutation, we notice that this CCN must always be here and should be permuted separately from the rest of the sequence. So in this case we are going to separate the CCN from the rest of the sequence, and we are going to split each sequence into the sequence CCN and the rest of it, and we will keep doing that until we finalize all the sequences. So let us now, after finalizing this split here, let's shift them to the left and start our calculations. Now each sequence is separated into 2 sequences, and this sequence here must be permuted separately from this sequence. So if we permute this sequence, we are going to generate elements for this set here, and if we permute this sequence here, we are going to generate elements belonging to this set. And now according to the multiplication principle, we multiply these 2 permutations together to get the total number of permuted sequences. So here we have the number of permutation for this sequence CCN and the number of permutation for this sequence here, and that is equal to 3. So for the second sequence we have to permute this sequence CCN and we have to permute the other sequence, and we multiply the results together according to the multiplication principle, and we get a 21 possible outcome. We notice that we are using the permutation formula of n elements taken n at a time with identical items. So for the sequence here, we are permuting 7 objects, taken 7 at a time with 6 and 1 identical items. And that's how we are applying the formula. So we keep doing that for the rest of the sequences. And finally, we add them together and we get 384 favorable outcome for the event of guessing correctly on a question 8, 9 and 10 exactly 2 times. Now to find the probability, we apply this formula here. Number of favorable outcome in the event divided by the number of elements in the sample space. So we add all these elements to get 384 favorable outcome divided by 1024, and that is 3/8. Thank you for watching and have a nice day.